So, good evening, everyone. And today is our second section of the day. And today we have uh, Miss Hamsadani, and she is
Yeah,
currently working as a project executive at Vistal Tried, and she have more than 3 years of experience in the remote sensing and GIS. So today she is going to give you an introductions about the GIS and along with the QGIS, and maybe it will be an interesting session for you. And I hope you enjoyed and learned a lot of things yesterday by Raghu. And today we have our another expert in the field. You can interact with her during the session, as well as you can keep communicate with her in the future. So I hope she will share the slides as well, and we can start the sessions now. And over to you, Hamsudani. Yeah.
yeah. Thank you. Thank you so much. And welcome to the QGIS live session. I'm glad to have you all here to explore the exciting world of geoinformatics along with me, Hamsatwani Selvan. Okay, I hope the common word we all know that together is GIS. Few things people can share about GIS that I could know how much you're aware about GIS. Just introduction, just few words. It could be an interactive session, just an icebreaker. Anyone? Okay.
So hi, I think if anyone of you want to introduce yourself to Hamsudani, then you can do that now. She really want that, I think, isn't it, Hamsudani?
Yeah. 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 Yes, I do.
Because we are very of people, yeah, we are very less number of people. So I think she's expecting that. Yeah. If anyone, maybe you can just speak or you can text in the chat box. Okay.
Hi.
We will address the questions at last. Okay, we will address all the queries at the end of the session. We are giving some time for it. Okay.
Hi, am I audible?
Yes, you are. And your name, please?
Hello. Myself, Yogeshwaran. I'm a master's student. I'm pursuing my Masters of Fishery Science here in
Oh,
Kolkata.
nice.
So basically,
Okay.
for my discussion, for my research purpose, I'm just including JS as one of my objectives. So, like, I'm currently
Great.
working on ichthyofaunal diversity. So, for that mapping purpose, I just get into these things like GIS for mapping everything spatially. So I'm
Okay.
just starting to learn these things. So I just came across this advert. So I just enrolled my name here. So
Okay,
I
that's
don't have much.
really great. You have come to a right place.
Thank you. Okay.
Okay. Okay, hope we can dive into the session. Okay. First, GIS is just a word which actually gives a powerful tool that is a geographic information system. So it is a powerful tool that allows users to capture, store, manage, analyze, and visualize spatial or geographic data. So it is actually data tied to specific location, whether it is a pattern or a relationship, whatever it is, a data is tied into a geographic location, specific location, whether it is city planning, it is disaster response, whatever it is. Okay, and GIS connects data to maps. It is actually integrating location where things are happening, whether it is raining, whether there is more smoke, where something is happening, and it is the location. Maybe it is on Delhi, it have more rain. Maybe it is on Mumbai, it has some accidents, whatever it is. So it is actually connecting data to map. So it is integrating location where things are happening with information what things are like there. I hope you have knowledge about remote sensing. You have come across a session there. Remote sensing is actually collection of data, and GIS is the processing of those data and visualizing it on real time with the satellite data or aerial imagery captured. we will actually store it, manage it, and analyze it, visualize using the GIS framework here. I hope everyone would understand this basic knowledge of GIS. Let me dive into the components. What is GIS actually? GIS is a geographic information made of spatial location data and attribute data. Whatever things you are handling, you should work with data. And here we are handling with two kinds of data, that is spatial location. So spatial location data is a data with a geographic component, as I said earlier, where something is happening. And attribute data is the answer for the question that what something is. So it gives the data about the geographic component there. So it is a database that contains the geographic information and it is called attribute data. And it can be used to summarize features, making queries, actually act as a metadata in GIS softwares. So geographic information system has some components with it. So it involves satellite, that is the source of data, hardware and software where we process the data, and actual data, that is, as I said, spatial data and attribute data, through which we'll make the analysis. As a result, we have the output in maps and apps. Okay. What GIS does? Most of the people only know that GIS can make maps. The actual purpose is making map, but GIS helps us to understand the patterns, the relationships, and trends. There are more than mapping. We have some other concepts in GIS. That is, one of them is data management. So GIS is a foundational system record of data. Here you can store, integrate informations from businesses and authoritative sources. So it is a major platform mainly for data management. Okay. And then comes the actual content, that is mapping and visualization. So from digital maps and dashboards to satellite imagery, maybe 3D, real-time, wherever it is, GIS brings data to life, helping us understand problems and solve them. Then just think of, okay, just think of maps that gives the answers for the spread of diseases. Recently, we have felt the issue of corona recently, maybe around 5 years. So we can hear that China is more affected, USA was somewhat affected, India was also affected. But only because of the real-time data, we can know how much a area was affected, what was the intensity. So that is what actually GIS is making. So then comes the spatial analysis, which only the location data and something what is happening with the calculative data, we can't do anything. So here we are combining both those things, where something is happening and what is happening. So most data has a location component where everything happens somewhere. With spatial analysis tool, in each software, we have different tools to make this analysis. We find hidden relationships and generate new insights from data. So here you can see the measurement. We can make measurements. I hope you all have used the Google map, where you can see the distance from one location to other location. The network analysis is similarly, actually it gives the optimized routes. It gives 2 or 3 routes to your location, where you can, which it gives both the distance covered, and you can choose your optimized route according to your time management and everything. And topological analysis is actually a major part, which is also done in GIS softwares according to the relationships of yard features. And spatial statistical analysis, as I said earlier, it is all about the different kinds of data in overall global level data or national level data with a statistical value analysis. And here comes the surface analysis with a new integration of GeoAI. Even GIS is integrated with AI nowadays. And then comes our communication. What GIS is about to convey, it actually gives some insights to the common people who were non-technical, who have no idea about what is GIS. It is actually giving us the common understanding, supporting collaborations and problem-solving issues. It, it just simplifies even a complex thing to a common users as well. This is what our main thought process to make the common people aware of happening things with more insightful data. I have handled with two data, a spatial and attribute. That is kinds of data we'll be handling. Here we have the types of data we'll be handling in spatial data. First comes our vector data. So vector or feature data is actually a categorical data that is stored as a geometric shapes. It actually has three types of geometric shapes, that is points, lines, and polygons. Points means it is just a single coordinate location. Maybe you can say where you are. It gives the latitude and longitude value alone. Maybe a tree, maybe a single building, whatever it is, your exact location. It gives a single X and Y coordinate locations. And then comes the line feature. It is used to define two or more points that are connected by lines. Okay, think of a feature like a river or a road. You can't specify it with a single point. It is actually a linear feature, so it needs to be identified with some lines. It is what actually is done. So the second type of feature is line, and the third is the polygon, where some area is closed with lines, is connected by multiple points. Say a boundary of a district, a boundary of a state, whatever it is. Even a building can be identified with a closed polygons only. So all these features you can see in Google Map, right? It denotes with points. There you can see the roads and rivers with lines, and all the buildings, all the areas were seen with polygons. So that is the easiest example that you can relate with. So it represents a discrete type of data, like buildings, roads, whatever it is. It actually used to represent the discrete type of data. And this vector data have some specific formats with it. So I have given some specific formats that SHP, GeoJSON, and KML. I will explain all these formats in upcoming slides, okay? So this is how it actually looks like. Points, lines, and polygons, and its representation in map. Hope it is visible and it is common for all. And now we can move to another type of data, that is raster data. Raster data is actually made up of matrix of pixels called cells, with each being the same size and containing a value that represents the condition for the area covered by that cell. So in most simple words, let me give you an example of raster data, that is nothing but satellite imageries. So raster data is a data that will be handling with pixels, where those pixels have some values and it represents the classes, the features on the real time. Here you can see what a raster data is actually and how it is being represented. Each and every color patterns has its own value. With that value, we'll be processing. So raster data, we have seen that vector data is a discrete type of data there, and raster data is a continuous data like temperature or elevation. Okay. So here raster data also has its common formats dot .tif, dot .image, and dot even JPEGs as well as raster data. So I hope every one of us have been handling raster data with us. Okay, I hope this is what the two types of data will be handling throughout GIS. Nothing apart this. Any doubts?
Hello? I think somebody's mic
Yes.
is on. Can you please turn it
Yeah.
off?
Okay, I'm proceeding it now. And we are now coming up to the applications of GIS, the actual purpose, why we are using this GIS along with us. And here comes the urban planning and infrastructure I have taken as a first use. So in that we are handling land use mapping. Land use is nothing but how a land is used, maybe for agriculture, maybe for constructing a building, maybe for some other purpose, whatever it is, how a land is used. We'll be map those data. So that is called land use. And we'll also handle with another data that is land cover. So it is a common word, land use, land cover data. Whatever applications you do, there will be this is one of the thematic layer in your process, land use, land cover data. How a land cover is used. That is land use, land cover data. It is it plays a major role in urban planning. And then comes the site suitability analysis for new roads, paths, and buildings. And this is this plays a major role in urban planning. Let us take an example of solid waste dump areas. It needs a huge area, huge land cover, and it should be away from the crowdy part where people are more denser. So it should away from the city area, and as well it should have a large space. So there were some site suitability analysis. It should not be agricultural land. So there are some criteria for that cases. We will perform this site suitability analysis. And this site suitability analysis is performed in various areas. One of them is solid dump waste. And then comes the utility and asset management. Okay, now our government is planning to give some water supply to rural areas. So without knowing the path or without planning how the water is going to flow, how we are going to provide electricity, it needs an actual planning that is also involved in GIS, in this urban planning and infrastructure. So all these will come under GIS, and it has its own thematic layers to be processed, analyzed, everything. So next comes to the environment and conservation. GIS is nothing without environment. Everything, each and everything, each and every field has, GIS has its own part, each and every field. Whether it is infrastructure, urban planning, or environment, even I have few examples in upcoming slides. I'll explain that. So first thing is deforestation detection using remote sensing. There will be a sudden wildfire, yes, forest fire. We can't detect it. We can't detect it with any AI. We can just monitor it with our satellites and analyze the impacts and make some prevention accordingly. We can take some actions and we can analyze its impact. So it will also come under this environment and conservation. And then comes the deforestation reduction. It is a major issue in this current era. Just trees are easily cut down. So it is also can be captured using remote sensing and processed with our GIS. And wildlife habitat analysis and protected area planning. So for this wildlife, like whatever elephants, lions, we can't handle it with in our homes or whatever the places we are. So it needs some specific area to protect those lives, those habitats, those animals. So for that, we'll also making this same site suitability analysis there also, and find the exact place. So we can't think just site suitability means, okay, this is outside the area, outside the city part, it has vast area, so we can proceed there. No, it is actually not in case of environment and conservation. Only we can plan if Karnataka area has more counts of elephants, we should plan accordingly for elephants. In Gir forest, we have more tigers or lions. We should plan accordingly. So we should have some praise for that particular animals. So if it is elephant, we should have more denser of forest areas. So according to the wildlife habit, we'll be planning those protected areas there. So again comes to our monitoring climate change effects. It was also one of the example in GIS. So, okay. Next will be the agriculture and land use. Here, the first thing is precision farming, where we can monitor the soil crop health and mapping the soil. Maybe some part of area has good black soil, where we can use accordingly we can plan the plants which we are going to be grown in that area, which area will be suitable for cotton, which part of area will be better for rice. So accordingly we can plan this with precision farming. In this image, I hope everyone can view how GIS is helping, like variable rate in seeding, on the go yield monitors to track variability. So it is also helps in monitoring land degradation and irrigation planning. And then comes the identifying pest or disease outbreaks using satellite data. In one of the recent issue with some kind of insects affected a lot of areas. Silifera, I hope so. So likewise, we can identify those pest breakthroughs with satellite data and actually find this actual reason with our spatial analysis processing in GIS and make decision making with those perfect results with accurate data. And then comes our transportation and logistics. Here, GPS plays the major role because it actually gives the exact position and it helps in route optimization and traffic management. Here, the best example always we go through is Google Maps and delivery zone analysis. Yes, Zomato. Yes, Zomato is also a great example where we track our food when the time with the distance. We'll all be sitting on the phone and thinking when will it arrive? Most of you did. So here you can see using GIS in logistics and transportation, it has multiple areas. Say customer segmentation, where most of the customers, maybe in Chennai, we can think Zomato will be in peak as compared to Tuticorin, Tirunelveli, Salem, because of the crowding in that area, because of the population in that area. Then comes our supply chain, asset management, traffic modeling, and the route planning. As I said earlier, which route we should take, and which will be the easier way to go according to our mode of transport, whether by walking or whether by cycling. And I gives you some tip. If you want a proper route without more undulations, choose car for that particular location. Then it will give, even if you are riding by bike, choose the car location, because car needs a broad area as compared to two-wheelers. So if you choose car for that particular location, to reach that particular location, you can have a smooth terrain, or else it will give some undulated areas to travel. So it will be one of your trick. Take it to your home with this session. And then comes the cargo monitoring and fuel consumption monitoring. Yes, to cover some 1 kilometer of distance, how much fuel you need. So this will help in fleet tracking. Some cabs, this will help in Ola. Likewise, where the drivers need more fuel for their traveling. So fuel consumption can also be monitored in dashboard. So then, as I said earlier, each of those data, that is vector data as well as the raster data, has its own extensions. The first and the foremost is .shp. This is the vector data format where we say this as shapefile format, where it actually, the function of this SHP is to store the geometry. As I explained, that point, line, and polygon, this particular extension helps us to store this geometry, where the shapefile, it was the shapefile main file. Shapefile is the whole format where it comes with different extensions, and a .shp is the main file in that particular shapefile. Okay. Then has the .shx. This is the index file for the shapefile, and it is mainly needed for spatial indexing. And then comes our .dbf, which is actually attribute, which actually used to store the attribute table, that tabular data. And then has our PJR, which stores the coordinate system and projection information. It is also one of the important file here. And then comes our GeoJSON and JSON files. So it actually used to store vector features with properties in JSON format. So this is actually used in WebGIS. Great for web and APIs. Maybe used in some application development or web maps. And here is the next will be the .kml, that is keyhole markup language. It is also used to store the geographic features, but it actually works in Google Earth. And again comes to our .kmz. It is the compressed version of KML, which again includes images and styles of that particular geographic feature. And .gdb is the file geodatabase. It is particular to ESRI software, that is ArcGIS. Folder-based storage for many feature classes. We can store a database inside this particular geodatabase file. Okay. Next comes our raster data, where I explain it as pixels of data, .tif, .tiff. Both gives the geotiff format. It is actually a raster image with geospatial metadata. It supports multiple bands. Say Landsat 8, we will download Landsat 8 in this format only. We'll download those data in. We can prefer multiple platforms for downloading this raster, this type of raster data, where Landsat 8 is one of the satellite data with TIF format. Then Sentinel data, all these satellite images will have this kind of extension. And .img is mainly for ERDAS Imagine. It belongs to Hexagon, one of the geospatial organization. It is also a raster format with metadata, but good for large rasters and classifications. Maybe hyperspectral data where it has multiple huge levels of band. Then comes the JPG, and JPEG is a normal data. JPG is a raster imagery. Even our normal photos is also will be stored in the JPG. When you zoom that particular photo to large extent, it also will have pixels in it. Sorry. Rasters, requires.jpw for georeferencing. So if we need to implement this in GIS, we need some JGW files, that is nothing but JPG wall file, because it contains the coordinate value. Without coordinate value, we can't do anything with JPG files used for raster images for mapping. Then PNG file, that is portable network graphic. Images used for base maps and symbols. But the only thing is here the background will be transparent. Again, we can't use it as barely. We need some JPW files, that is also a world file, which contains the coordinate reference for PNG. Same as JPW, but for PNG. ASCII grid, that is, this was a text-based raster file that stores elevation and continuous data. GRD is ESRI grid, raster grid format, binary or ASCII, which is also folder based. This is specific to ArcGIS softwares. Okay, we are coming to a important part of GIS. That is, we are saying that we'll be handling with locations, everything. But what actually a coordinate system is, what actually a location is, how we will be handling it in GIS? That was the major question. And now, here is your answers. So, to correctly map, analyze, or combine spatial data from different sources, it's essential to know where things are on Earth. So, exactly the location. We may not know what will be the latitude, longitude value for our location. So we need that data. That's where coordinate system come in. So coordinate system provide a way to pinpoint any location on Earth using numbers, that is latitude, longitude value. So coordinate system is a framework used to define how the locations of geographic features are expressed. We actually expressed it in degrees, 8 degree north, 78 degrees south. Likewise, a coordinate system helps translate from the 3D Earth. We are living in a Earth that will be in spherical shape, and this coordinate system helps to translate this 3D location onto a 2D map accurately. So without coordinate system, your data may appear in wrong location because we don't know where to locate that particular data. So there are types of, we have some types of coordinate system. So first one is geographic coordinate system. Second one is projected coordinate system. And here is a visual representation of both geographic coordinate system and projected coordinate system. So geographic coordinate system uses latitude and longitude. in degrees. And this particular GCS, that is Geographic Coordinate System, is based on 3D model of Earth. Here we can use WGS, that is World Geodetic System 84. Here they have given example for New Delhi. Okay. I hope there's a little task for everyone. Just after this PPT, I'll give a live session of QGIS. In that break, you can, in that few seconds, you can go to your browser and take your latitude, longitude value for your own location and just pin it in the chat box. Let me see wherever the students are located. So it will be just an interaction, so that makes you more clear about this GCS. And as I said, it is actually represented in the Earth's spherical surface. And this projected coordinate system helps us to convert the 3D Earth to a flat 2D map using mathematical projections. So here we say northing and easting. There we say latitude and longitude. So there in GCS, it will be represented in degrees, but in PCS, it will be represented in meters or feet. And the common example is universal transverse Mercator. And how this coordinate system works in QGIS particularly. Okay, every layer in QGIS has its own coordinate reference system. This CRS defines how coordinates are measured and which map projection is used there. If layers use different CRS, we need to reproject them to align. Maybe one layer may be in WGS 8444 north, and other layer may be in WGS 8445 north or 44 east. So we need to reproject them to a single CRS. Now again, here I have an example. If you plot New York in wrong CRS, it may show up in ocean. So now you can match how this CRS helps us to plot each locations exactly. So choosing the right CRS ensures all layers align correctly. And here is our GIS software. QGIS, Quantum GIS is the open source free software, free GIS software, which everyone is using, and it has extensive plugin support. It is ideal for mapping, analysis, and customization on desktop. Next comes our Google Earth Engine. It is a cloud-based platform with access to massive satellite imagery data set. We don't need to download some data set and process it. We can have it in cloud and process it. So best for remote sensing and environmental monitoring using coding, but this involves coding with JavaScript and Python. And next is our ArcGIS. It is actually a powerful commercial GIS platform, but it is actually needs some licensing. It is proprietary to ESRI. This platform has some advanced spatial analysis tools, widely used by government project and some large scale of GIS projects for enterprises. And these are the logos for each particular softwares. And I have taken some other softwares for your reference, which is SNEP. This is from European Space Agency. This is also free software for processing particular sentinel data. Sorry. This is for SNAP. And then comes our GRASGIS. It is also open source. We can take it as along with QGIS, great for advanced spatial analysis. And next comes our ERDAS Imagine. This belongs to Hexagon. Another proprietary software belongs to Hexagon. This is specialized in remote sensing and raster data processing. This is ERDAS Imagine. And this is how QGIS interface looks like. We'll also see in real time, but just a glimpse I have given to you. Each and every numbers represent its own value. In upcoming slides, we can see, but I have given the fifth bar here, which provides the live feedback and controls, including you can see the coordinates, the scale and rotation. This is the CRS, coordinates reference system. Okay. And the first one is menu bar. This menu bar contains all the access, uh, including the project. We can open and close project here, edit the map here, edit the particular project, have some settings, arrange some settings, and an option tab for layer, adding layers, particular vector processing, vector processing features, and raster processing features. This is menu bar. And then comes the toolbar. It is a quick access button for commonly used tools. Add vector data and raster layers, identifying. Actually, this is processing toolbar, where we use major analysis, where we use tools for major analysis. Again has our browser panel and layer panel. Browser panel is in the left. Let us to browse and quickly load spatial data from local folders. And layer panel is actually contain all our layers, show all the active map layers, their order, symbology, and visibility. Map canvas is the main area, main workspace where loaded layers are visualized. Shows vector and raster. It also shows both vector and raster data. Supports panning, zooming, and real-time map updates. And this is about our theory part. Let me open my QGIS interface. Okay. So wherever I go, you can see the coordinates here. It is just scrolling accordingly. So first, let me introduce this interface to you, where we see that menu bar, project. We can open new project here or open the previous projects, and it helps us to save, import or export features involved. And here we use the print layout. Once the map is ready, we'll make the layout for that particular map. Edit view, edit tab and view tab. Layer panel. And now we are going to add layer, add raster layer. In this, let me take Tamil Nadu shapefile first. Because my location is from Tamil Nadu. I just chosen Tamil Nadu, nothing else. Just a minute. I do have the India shapefile here. I'll look into it. Yes. Okay. Here we have the India shapefile. But I hope you can see the layer panel. This is our layer panel. Actually, we have the Tamil Nadu layer behind this India layer. So what? It is not visible. So we're going to align this. Just drag and drop. Now you can see the Tamil Nadu layer here. So this is actually a shapefile of polygons, different types of polygons. I hope I do have raster layers. Okay, let us work something with this. I'll show the attribute table for this Tamil Nadu shapefile. In this column preview, you can view the district-wise names. So if I mark one of the district here, we can visualize that particular district selected in our shapefile. See, I hope it is visible. And it also gives the labeling with, it also shows the label Chennai. Each and every location shows its own label. And we can also open the attribute table for India shapefile. We can view the different states here, where we can choose which one. mm, Anyone can suggest some locations, so we can select it and view it in our map. I'll also share some plugins with you where we can see the real-time view of that particular location. Any suggestions from your side? No. Okay. Then I choose our capital, Delhi. We can see Delhi. Where was it? Okay, here it is. Okay. Now I'm just going to save this particular shapefile with different color. So there, for that, we need to go for symbology. We can go to properties. In this symbology, you have some single symbol, or you can categorize it and graduate it. Categorization means we have values. I have chosen the India shapefile, so I'll give the variable of 1, classify it. So we can have a colorful map of India. We can also display the labels here. Actually, we can have an option. Nice, sure. Okay. I'm just right clicking that particular location for knowing the particular latitude longitude value. But labels will be shown. Maybe it needs some other. We can also go to symbology to specify the labels. Single color is better for this, actually. Okay. By selecting this value, the labels will be displayed there. Okay. So we can have all those names against each states. Okay. So in this map making, there are two kinds of map. That is chloropleth map and isopleth map. If you have data in attribute table with an increasing or decreasing order, you can prepare both of these maps. So I have those examples also for you. So examples of chloropleth map is this, where you can see the graduated difference. This is one of the map I have created for women literacy rates across India in 2023 with 2023 data. So with the for if you need to prepare this kind of symbology, you need that feature of graduated one in the symbology. So here I have chosen category because we have different categories only. So if you have those values in your attribute data, you can use the graduated one. So we can classify it according to classes, maybe 5. It is equal count means if you gives 5, you can also gives in equal intervals. You can give as much as you want. Apply. Since I don't have that particular feature, it choose in white color. So we can change this symbology. Everything color ramp is in white color. So that I choose that category option particularly. Classify values. We two kind of data, but why? Just a minute. This is the chloropleth value. Sorry, chloropleth map. Maybe we can also view the attribute table ID 10. Based on the ID, it was actually given this chloropleth map. It is generated this chloropleth map. So ultimately, Uttaranchal, Uttar Pradesh will have the highest value. So it was most it given the dark shade for those areas. Okay. Since I have selected Uttar Pradesh, it was reflecting in the map. And another type of map is isoplete map, which also gives the same kind, but only thing is it actually gradually change in a linear way. Let me also give the some example for that also. If you once visualize it, it would be more easier. So like this, it will vary according to those values. It will make some linear separations accordingly. So this is what isoplete map is. It is mainly used for rainfall, maybe heat maps. Contour maps mostly looks like this, where you have some range of value. For a particular value, you can use chloropleth map. For some range of value, you can use isoplete map. I hope you're all clear with this types of map. And this is about the symbology. I'll give you some plugins to know more. Before that, we can prepare this particular map layout. So this is the icon for map layout. Whenever you create a map layout, it will be stored with some ID. You should give some number to that particular map. Whatever you like. I'll giving 5. So this is the canvas for your map. And if you want to add your map here, this is the icon for add map, where you have a sheet with a plus. This is for 3D maps and this is for 2D maps, that is add map. Now I am giving this add map field here. Here we have a map. Okay. What are all the components of a map you think? Any ideas? Any people have some ideas? So whatever may be the map is, whatever thing is, even for a book, we need a title. We need a name. Even for a person, we need a name. For a location, we need a name. So likewise, for this, whatever map you are preparing, you should give some title to that particular map. So now I am going to give the title bar. Okay. You can customize this title. I'm increasing the font. I have changed the position from left to center and top to middle and just India. In both the maps, you can see I have given some title. So women literacy rate across India. Another one I have chosen as rainfall map. I hope so. I've given that title. Then, then comes our legend. What each value represent. Okay. We are having a too long legend that there were options to split this particular legend. Okay, sure. Symbols are okay. Columns. Here we can give the count of columns you need. Equal with split layers. So if you have larger data, then you can here move the item content there. Okay. I'm removing this layer right now so that it won't display in the layout. We have this layout here. So we can also change the particular layer name. States. So it will be displayed accordingly. Here you can see the name states. Then comes our scale bar. It is actually from 0 to 500 kilometer. And also we can place our north arrow. There are different types of arrows. I'll choose this one. Okay. These are the components of a map. Legend, scale bar, north arrow, title, everything. Okay. If needed, you can also add a grid here. But it is okay to project the same because we have too many values in legend. If we place grid, it will not look good. Let me move this map slide turn. Can we make this even smaller? No. Okay. I hope it's better. Okay, we can print this, export this as image, SVG file, even as a PDF. So I prefer to export as an image. So we can give a name, states, save as PNG. Save. This is how we have saved our map layout. And let me introduce some plugins to you. So mostly used plugin was the Quick Map service. Actually, I have installed it already. So if you're installing for first time, you can give here the text will be install plugin. So I'll show how the plugin works. This is the Quick Map service. So here you can use different maps as your base map. So I've already chosen two maps. One is Google terrain map. So just I'll type Google here. So it gives lots of maps. Google map, Google satellite. But we have satellite hybrid also. I don't know why there isn't. Okay. And best is OMS, OSM, Open Street Map. Okay. Mostly learn some shortcuts while interacting in an interface, whatever application is this. So for removing a layer or a group, we need this. The shortcut will be Control D. And this is the icon for remove a layer or a group. And this is the icon for adding the group. So in this group, I'm just dragging and placing it into a group. And I'm taking this state into a group. Sorry. So both comes into the same. So our states are visible using this satellite imagery. Okay. So let's take it out there. Okay. So this is how we can add a base map for our particular map. If we have this hybrid, we can see each and every names for that particular location also. This is how OpenStreetMap looks like. Okay. Let me give you some mini project ideas so that you can also explore the essence of GIS. So the first and foremost thing is thematic mapping of Indian states. It just need India shapefile, and you can download the shapefile in different formats, different platforms. First one is Survey of India. Again, you can download in Bowen. Even in Google Earth, you can download some features, particular point or location. You can download in KML and convert it into shapefile. Another platform is Devices. These are some platforms you can download your shapefile format. So first thing is making thematic mapping. So as I said, you can create a chloropleth map using maybe categorized symbology or a graduated symbology according to your attribute data and make it as a image or a PDF as you want. And then you can use a mapping public facilities. You choose your particular district. You can choose some specific category, maybe schools. Where are the schools are located? You should collect that data first in an Excel, and then by using joins, by using joins, where is it? Sorry, using here is the joins. Here, if I have uploaded uh, some files, it will display here. Since I have not uploaded any Excel file, there is no chance to view that. But this is how the pop-up actually looks like. If you have your Excel file with the same data as like in the attribute, but some values, some different values, you can add that particular field here to add the numerical values. So this is how you can do for schools or particularly that particular sector, that particular feature into your map. So mapping public facilities, mapping schools, mapping colleges in your locality or even in India. That is up to you. So for that particular thing, you should use, if you choose that, you can also learn how to create point shape files. So land use, land cover visualization. For that, you need a raster data, and raster data can be downloaded in various places. As I say, ESA for Sentinel data. If you need Landsat data, you can go to USGS, United States Geological Survey. Landsat 8, Landsat data for USGS, Sentinel data ESA. Even you can download Sentinel data in USGS also. If you need Cartosat data, you can come to our Bowen, Indian platform for satellite data. So with that data, you can perform some raster analysis for land use land cover visualization. And again, road network and accessibility map, overlay the road shape files of India or your locality, and you can use the buffers, also one of the spatial analysis to visualize different types of roads, highways or major roads, even local streets, whatever it is. Same thing for rivers also. You can visualize these streams of different rivers. Population versus climate analysis data. These are some of the project ideas you can explore in GIS, but there are many. GIS is a sea you can dive and enjoy there. I have done some of my examples where one I have shown to you. The other thing is startup distribution in India. Almost for 3 to 4 years I have done. 2019. This is the condition for 2019. If I given hashes means there is no counts, no data available in that particular district in that particular year. Then startup distribution in 2020. In COVID time only there is a high level of startups. 2021 is done, and 22 and 23. Okay. After I created these maps, only I can see how colors influence your map a lot. Only this is the thing I have learned mainly from this map because red is the more dominant color as compared to other colors in my map. So while choosing your symbology, think wisely and work in it. And hope I have done with my session. And now it's time for question and answer session. Okay, let me stop this presentation first. Okay, there were received some 8 chats. What?
Hello,
Yes,
Hamsidani. Hello.
yes,
Yeah,
yes,
I
and
think you finished the session, right? Yeah.
yeah,
So now we can move to the question and answer session, and
yeah.
I think maybe the participants might have some questions, and they
Okay,
already asked few questions earlier, maybe even the beginning of our session.
okay.
Okay, I
Sorry,
think
in your chat
from JD.
boxes, you have given some districts. Since I am sharing my screen, I have not come to this chat box. And first of all, sorry for that.
No, no, actually, I can pick up the questions and I can tell you or I can inform you what are the questions in the chat box. No problem.
Okay, okay,
Okay. Uh, so maybe there was one question by Jaydeep, and he was asking which software we are using and are using to create or modify the spatial or vector data. That's what he asked. I think
okay.
he might get the answer now. Eh?
Answer. Yeah, I hope
Yeah,
so.
because that was our session about. And I have
Yeah,
a request. I think in the QGIS, whenever we had our Indian map, we don't have our Ladakh and Jammu Kashmir, all the sessions. Okay. Maybe that's a issue with the QGIS. Actually, I noticed that earlier itself, and we are going to inform that to the ministry and all. Maybe very soon. I already prepared the letter. So
okay.
because we
That's
need
great, actually.
the whole Indian map whenever we are creating it. So I just want to like if you can give any uh, suggestions on that as an expert, or that will be also beneficial because you are widely using QGIS and all. And whenever we are going to the Indian surveys map, it is not that much easy to assess. There is a lot of steps to take. So I'm requesting them to get more access to the map of India from the survey of India. And if we can collectively get some signatures and we can send the letter with more authenticity. Okay. Mm. So there are some questions. There is any possibility to measure the depth of the water or any particular area by using the QGIS or GIS?
Yes,
Yeah.
actually, measuring the depth of the water is a particular particular science that actually we name as bathymetry. In a particular area using GIS, which involves combining data sources with spatial analysis techniques, GIS itself do not have direct ways to measure depth directly. So it processes and visualizes data collected through various methods. One such science is bathymetry, but we can visualize the depth in QGIS with some this bathymetric data downloaded and processed. We have some particular steps by using contour lines and interpolations. We can perform that particular. It is also one of the project idea you're having. So you can choose some of the river and download some DEM data for that particular area, and you can load it in QGIS and as usual coloring the ramp whatever it is, and you can perform first generate contour lines for that to show the depth intervals, and then calculate the statistics for the depth ranges and use this interpolation technique to create the continuous bathymetric surface. ArcGIS is really different because it is totally licensed. You should pay some amount for ArcGIS if you need to use ArcGIS. Uh, and ArcGIS has some extensive plugins than QGIS also. It is actually major for enterprise level, where we will be handling with more large kind of data. But QGIS also supports various plugins than ArcGIS. Um, in data accuracy, I would prefer QGIS only. Yes, ArcGIS is more advanced because ArcGIS have different sessions with the different components with that. It has its own Arc Desktop, Arc Map, Arc Online. We have Arc Online for WebGIS, and Arc Scene for 3D visualization, and Arc Globe for this. As Google Earth Engine, we have Arc Globe there. So it has some multiple components inside it. This is what the major difference is. And QGIS is open to all. It is open source. Anyone can use. Mostly students and researchers prefer QGIS. ArcGIS maybe organization level and government projects are mostly handled with ArcGIS only. I hope so. Okay, thank you. Thank you so much. Easy to
Okay, thank
use.
you.
Yes,
Yeah,
QGIS
thank
is
you very
easy to
much.
use.
And yeah, I think it is more about the affordability, especially for the young budding researchers and master students,
Yeah,
right? Yeah, okay.
sure,
And
sure.
that's why we introduced this course to the students. Hmm, okay,
Even ArcGIS more accurate than QGIS more accurate than ArcGIS. It has extensive plugins.
okay.
Yeah. Data accuracy
So,
is better in ArcGIS only.
okay. QGS is
Yes.
more accurate than the ArcGIS, isn't it?
Yeah. Yeah.
Okay. Yeah. So I think maybe if anybody else have any questions, they can turn on their mic and ask the questions. Otherwise, we can wind up today's sessions and because it's going to be in 1.5 hour, and as we promised, we finish within 1.5 hour, and we have the recordings of the session. And if you want to have the recording, then we will share that with you. And due to the monsoon and all, some people from Kerala and or was unable to join, so I will share them, share the recordings with them, so I can also share with you as I promised. And about the certificate, for the two separate courses, we will have two separate certificates because some people joined yesterday only and some people joined for today's only. So we have two different certificates for this course. Okay, we will provide you in maybe in 1 week of time. Okay, so you can reach out to me at any time. And for the slide, if you need, I will request Hamsadani for the slides. And whenever she's like share with me, I can hand over that to you. Okay. And another small notice is we will have our another session or another class that will be on August 16th or 17th. And if any one of you are interested to join, then you can join. And that will be on the remote drone technology, drones, the applications of drones in remote sensing. And it will be an expert from the Tata Steel. So stay tuned for the all the updates and the sessions. And mostly it will be on Saturdays and Sundays, 7:30 to 9. Okay, IST. Okay, any questions or any clarification that you need? Anything? Hello, the participants. Hello, Hamsudani.
Yes,
Okay,
yes, yes, you're audible.
yeah,
I hope everyone was
yeah.
clear with the concept. I hope so.
Yeah, it was because we will send them a feedback form and I will let you know their comments. No problem. Yesterday it
Okay,
was nice
okay.
sessions by Raghu. And okay, yeah, definitely. We can share the contact. Yeah, okay, yes.
Sure.
Okay. So we can wind up today's sessions. Okay. Okay. Thank you very
Thank
much.
you. Thank you for all your patience. Thank you. Thank you for this beautiful session. Thank you.